is the generator for each of the following sequences? So when I speak of a generator for a sequence, right, the two generators that we've been talking about are either you're multiplying by the same value each time or you're adding the same value. And yes, if you are multiplying by 1/2, that is the same as dividing by 2, but you're better off as thinking about that as multiplying by 2 because that's the common ratio, and it'll help you get the expression for the nth term better. So for this first sequence, I can tell each time I am subtracting an additional 3. On your paper, if you just put -3 and you didn't tell me what, I don't know if are you subtracting -3? Are you adding -3? Are you dividing by a -3? I don't know. So make sure that you put a complete answer for this. The first part should have been like subtract, or I'm sorry, probably add -3. So each time we're adding -3, it's decreasing. The other thing that you need when writing the nth term for an arithmetic sequence, well, actually, they didn't ask that, did they? This is a simple question. They're just saying, what's the generator? So for this one, you're adding -3. How do I know? I know that because each value is 3 smaller than the previous one. So, and I'm going to write that in words. Make sure you have it written in words as too. Each new value is 3 less than the previous value. Okay, and in the next equation, they actually gave us the rule. They're saying T of n equals 0.5 or 1/2 times n minus 6. On this one, guys, what is the generator?
Adding 0.5 each.
Excellent. Yes, we are adding 0.5 each time. And one of the ways that you can say that you know that is you can say in general, T of n, this is for an arithmetic sequence, equals A times n plus B. This value right here is your generator if it's an arithmetic sequence. It's what you're adding each time. And if you think about it, it's rather clever because if I'm adding a 1/2 and then a 1/2 and then a 1/2, what it's saying is that's repeated addition. If I want to know the third one, I need to add a 1/2, a 1/2, and a 1/2. And I can go with my calculator plus 0.5, plus 0.5, plus 0.5. If I want to do that for the fifth term, that's plus a 1/2, plus a 1/2, plus a 1/2, plus a 1/2. That gets old when you're in and out of your calculator. So that's why we have multiplication. It allows us to represent repeated addition. So I'm adding a 1/2 5 times, and then plus I've got my starting value, my 0th term. By the way, if that is a sequence, what's the first term in that sequence, class? No. For B. What's the first term?
-6.5.
What is it?
-6.5.
Try again. -5.5. You're adding a 1/2, right? So when you put in n is 1, that gives you the first term. It's 1/2 minus 6, so it's -5.5. The 0th term is what? Yes, David. And you can see it right there, right? This is always going to be, and in fact, I should put this here. This is the common difference. This is what I'm adding each time. And this is my 0th term. 0th. I don't know. They wrote that 0th. Is there an E there? Or it's just a TH. There's no E. Thanks, Kelly. 0th term. And then for the next sequence, I'm going from 32 to 16 to 8. What's the generator for this sequence? Yeah, think about it. Pause the video if you know. Shout it out loud. I think it's what? Dividing by 2. In terms of multiplication, what are we multiplying by?
0.5.
We're multiplying by 0.5. And I like to just say 1/2, right? But we are multiplying by, sorry that M went away, multiply by a 1/2. Okay. Let's go on to questions. So those are generators, and that's actually a question I think probably should be at the beginning of the test, because there's a lot of questions at the beginning that are a lot more complicated, but you have to know how to find and identify the generators. Question number 11. So question 11 says solve each equation after rewriting it in a simpler form. And you know, at the end of the day, I looked at all of your work. You guys did pretty good jobs on solving these linear equations at this point. If we just step through the process for this first one, probably I would use the distributive property and multiply each of these terms by a 3. So this would become a 9x and then minus 6. Notice 3 times negative 2 is negative 6. And then next I would have a plus 6, which is fun, and that equals 6 times x minus 15. The reason why that's fun is I end up having a number and its opposite right next to each other. Negative 6 plus 6 is just plain old 0. So on the left-hand side, we can write 9x is the same as 6x minus 15. And if I take away 6 x's from each side, that gives me that 3x is the same thing as negative 15. And then when I divide by 3 rather, I get that x is equal to negative 5. So most of you seem to have no problem getting that. That's the answer. And I really appreciated, Brandon, your guys' group, all 4 of you, I don't know who wrote it down, but you did a super job of including the check. And it was indisputable. Not only did you have the right answer, but you proved to me that it was the right answer, and I appreciate that. Although this question didn't ask for it, it's just a great thing to do because then you know for sure you've got all those points. The next question you could take, you could go one of 2 ways, right? You could, if you chose to, you could multiply both sides by the number 9. If I multiplied both sides by the number 9, this would be the fraction buster technique. I'd be getting rid of fractions. And just to show you what that would look like, if I chose to multiply both of these by the number 9, I might write it as 9 over 1. It would look like this. So this numerator would be 9 over 1 times, parentheses, x minus 5 over 3 equals 9 over 1 times 27 over 9. Now there's a lot of good benefits to that, right? First of all, on the right-hand side, I can see I've got a common factor of 9. If I chose to rewrite it, you guys see I have a 9 in the top and a 9 in the denominator. That's a big 1. So 9 over 9 is 1, so I could just write this as a 27. Over on the left-hand side, 9 is 3 times 3. So if I wanted to be real explicit, I could write it as 3 times 3 times an x minus 5 all over 3. So you guys can see there's a big 1 there also, right? So that's 3 times the quantity of x minus 5, which would be 3x minus 15. So if I was to eliminate the big 1 and then distribute this 3, this is 3x minus 15. I hope you understand where that came from. I'm just distributing this 3 to both the positive x and to the negative 5. And then over here I have that equals the number 27. If I choose to next add 15 to both sides, this becomes 3x, and I don't know, 27 and 15 more is like a 2 carry. It's like 42. That equals the number 42. And I believe if I divide 42 by 3, I get that x is equal to 14. So that's one way to tackle that. And I saw at least one group use that technique, multiply by 9 to eliminate, or to get rid of the fractions, right? Fraction busters. The other thing you can do is, because this is a proportion, right? I have a ratio equal a ratio. One of the things that you can do is you can, in a proportion, and I want to be careful and keep stressing, it's just a ratio equal another ratio. The cross products are equal. But you know what? Even looking at that seems silly, because what's 27 divided by 9?
3.
Yeah, you know what? This would even be easier. I could just rewrite this as x minus 5 over 3 equals the number 3. Now what could I do to both sides? Yeah, multiply by 3. And so now I've got x minus 5 is equal to 9. And if I add 5 to both sides, I also get 14. That was sweet, right? And I still think some of you are saying, yeah, you still did it a different way, and that's okay. But that was nice. But you could also do this. This product is equal to this product. So if you were to multiply 9 times the quantity of x minus 5, that would be the same thing as 3 times 27. But really, this is I think that's brilliant. Last question then.